So, okay, imagine trying to manage this huge Wi-Fi network,
Uh-huh.
maybe hundreds, even thousands of access points, setting each one up individually.
Yeah, that sounds like a complete management nightmare.
Exactly. So today, we're going to dive deep into AP management, specifically looking at high-performance networks. Maybe you like those using Huawei's Cloud Engine S16700 series switches.
Right, those are pretty powerful. Often the core, handling tons of connections, enterprise stuff.
And our mission really is to see how centralized AP management doesn't just, streamline things.
It cuts costs significantly.
And it reveals some surprisingly clever features that make these complex networks actually work well for you.
Yeah, optimize them. So where do we start? The basics.
Let's lay out the players. In any big double LAN, you've got your devices connecting, right? Phones, laptops.
We call those stations SDAs for short. They connect wirelessly.
To the access points, the APs.
Exactly. APs are the bridges, connecting those wireless SDAs to the wired network infrastructure.
Okay, SDAs, APs, but what's pulling the strings?
No.
Managing all those APs.
That's the wireless access controller, the WAC. Think of it as the central brain.
The brain. Got it. So if you have hundreds of APs, the WAC is essential.
Absolutely vital for large scale. It orchestrates everything. And how that brain connects to the APs, well, there are mainly two ways.
Yeah.
First is the FIT AP architecture, pretty common. Here, the WAC handles the heavy lifting security management.
And the APs.
The common APs just provide the radio access. Simple, effective for a lot of places.
Right. Sounds solid. But what about those difficult areas? Old buildings, thick walls, maybe dorms or hospitals where signals just die.
Yeah, signal killers. That's where the second architecture really shines. The agile distributed architecture. This is kind of the aha moment for tricky deployments.
Agile distributed, how's that different?
So the WAC manages what are called central APs. Think of them like powerful hubs maybe on each floor.
Okay, central APs.
And those central APs then manage smaller remote units, or RUs, often like wall plates.
RUs, so like one in each room almost.
Exactly. Perfect for hotels, hospitals, dorms. And RU gets its signal from the central AP down the hall. And here's the clever part.
Yeah?
They connect using standard Ethernet cables, not those thicker, lossy antenna feeder cables.
No, so you can run Ethernet much further, right?
Much further. So you can extend coverage deep into buildings really efficiently without the signal degrading like it would with long antenna feeds.
That makes a lot of sense for complex layouts. Okay, so you have the WC, maybe central APs, RUs. How do they all talk securely?
Good question. That's where CAPWAP comes in.
CAPWAP.
Control and provisioning of wireless access points. It's basically the standard language, the protocol, that lets the WAC and all the APs communicate.
So it enables that centralized management, sending down configs.
Precisely. Huge improvement for O&M efficiency. No more touching every AP. But the security part is key.
How so?
CAPWAP uses DTLS encryption for its control tunnels.
DTLS, isn't that like TLS, but for UDP?
Exactly. UDP is normally connectionless, right? So ensuring privacy and that packets aren't tampered with, that's crucial for control commands. DTLS provides that security handshake.
Without the overhead of TCP. So it's secure and efficient for real-time control.
You got it. Secure, fast delivery of configurations. Essential for these big dynamic networks.
Okay, so an AP needs to get online. It's not just plug and play, right? There's an onboarding process.
Definitely. It needs an IP address, first off. Then it has to establish that secure CAPWAP tunnel back to the WAC.
And access control, making sure it's a legitimate AP.
Critical. That can use its MAC address or its serial number. There's authentication. You can even have whitelists or blacklists. Only authorized APs join.
Makes sense. And once they're online, configuring potentially hundreds of them. This still sounds like a lot of work.
Well, that's where AP groups come in. A huge time saver.
AP groups. So you group similar APs together.
Yeah. You define settings once, say, for all APs on the third floor, or all APs serving a specific function, apply it to the group, and boom, configuration pushed to all of them.
Batch configuration. Less manual work, fewer mistakes.
Exactly. Think about deploying a new section or just updating settings. Saves time, reduces human error. It's subtle, but it really impacts efficiency and, your budget.
Okay, beyond just basic config, are there other sort of clever management features?
Oh, yeah, some really thoughtful ones. Take the little lights on the APs, the AP indicators.
The status lights.
Usually they just blink, but with these systems, you can actually turn them off remotely.
Turn them off. Why?
Think sensitive areas, Hospital rooms at night, maybe high-end hotel suites. You don't want blinking lights disturbing people.
Ah, good point. Minimal disruption.
Right. But conversely, say an AP goes down in some huge confusing server room or ceiling space.
Right.
You can make just that one AP's indicator blink remotely. Makes finding the physical unit way easier.
Oh, that's actually brilliant. Better than trying to trace cables or read faded labels.
Been there, done that. It's a lifesaver sometimes.
Yeah.
And then there's remote debugging.
For hard-to-reach APs.
Exactly. Maybe it's mounted way up high or in a locked closet. Instead of getting ladders or keys,
You can.
you can log into it using a Bluetooth serial port connection from your phone using an app like Cloud Campus.
Seriously. Via Bluetooth.
Yeah. Think of the safety aspect, no climbing, and the time saved. You diagnose it right there, cuts down operational costs, and speeds up fixes.
Wow. Okay. That's pretty practical. So let's bring it all together for you listening.
Mm-hmm.
Centralized AP management, like we see with these Cloud Engine switches, it's clearly not just about basic control.
No, it's about smart design, like that agile distributed architecture for tough spots. It's a robust security with CAPWAP and DTLS.
And these really practical, thoughtful features, turning off lights, remote blinking, Bluetooth debugging, that make managing these big, complex networks actually, manageable.
And cost-effective, definitely.
So here's something to think about. In this world where we're just getting more and more connected, Wi-Fi is like utility grade now.
Absolutely essential.
How do you think these deep, granular management capabilities will need to evolve even further? What other, maybe invisible layers of control are shaping our digital experience, making it seamless and optimized?
That's a great question. Handling even more device types, dynamic environments, the intelligence layer will just keep getting deeper.
Definitely something to mull over. Well, that's our deep dive for today.